Up to this point, we've just been looking generally at arithmetic sequences in series and geometric sequences in series. In Unit 2, we're going to see how we can use some modelling processes to model some sequences arithmetically and some geometric. And a key point to that is looking at graphs. Now, in arithmetic sequences, you'll notice there's a nice linear progression. In all three possible cases, we look at linear growth, or if you like, linear decay. For geometric sequences, as you're multiplying by a common ratio, we've got the prospect of a growth factor. That's when your R is greater than 0. Should be greater than 1, I think. Now, when R is between 0 and 1, we can see a decay sequence. If any of you do physical sciences, that's the type of thing we'll see with radioactive decay. Slightly rarer, but if we're dealing with decimal cases, we have a couple more growth and decay sequences. The flat line, or the steady state scenario, and the stranger alternation if we're dealing with a negative number between 0 and -1, and when R is less than -1. Clearly, your graphics calculator is going to come into its own. I'll be demonstrating some of these questions using the Casio Classpad. If you have a TI, a little bit trickier to work with, but still very possible. Now, V2.1, first instance, we've got an arithmetic sequence, second one geometric sequence, R's between 0 and 1, and the third instance, a geometric sequence where R is less than -1. Now, each of these problems here, what we have to do, we have to set up the grids like so. Actually, this last one, I think we might have to actually set it up so we've got the 0 in the middle. It's a common mistake that you can make. The first instance, we're progressing upwards in 5s, so 15, 20. So when we graph that, please notice distinct points. We're beyond the given data, but you can see the nice upward progression occurring. Now in the second instance, we're multiplying through by 0.5. I could generate these on the calculator, but really it's a halving in each instance. So 80, 40, 20, 10, 5, and 2.5. So when you come to gridding that, 80, 40, 20, 10, and so on. In the second instance, because we're halving, 80, 40, 20, 10, 5, and 2.5. In the third instance, with a sequence such as this, it's far easier to put it into your calculator. So 5 times, open bracket, negative, that's negative in brackets, 1.8, close brackets to the n-1. And you can see here we generate the sequence 5, -9, 16.2, and so on. So use that to do the hard meters in that question. And when it comes to graphing, you can see that alternation I referred to earlier in the video. Please notice this last scenario is one you won't find modelled too often in the course, but still showing with the calculator, very, very easy to model. And although we're not quite up to it, you can see how very quickly we can generate that on the graph. So graph, and I've chosen gplot, AN, and not the sum, but you can see the points going up and down around the axis. I've extended it beyond the points required but very easy to generate, and it will be particularly handy to get familiar with the graphing feature as you go through this unit.